Hi everyone, Adam from the CDK team, and today I want to show you a quick proof of concept of speeding up CDK watch. So if you're not familiar with CDK watch, it's a way in the CDK to invoke a command from the command line, which will then observe the files of your project, and anytime any of those files change, it will automatically trigger a deployment for you without the need for you to explicitly invoke CDK deploy. And by default, Watch uses so-called hot swap deployments, which try to skip CloudFormation in certain circumstances and update your resources directly. And we have this issue in the CDK repository that talks about a potential performance optimization of skipping synthesis if a given change to a file is to an asset as opposed to part of your CDK code. So I want to show you a proof of concept of what I've been working on, how to implement this speed up, and what is actually the speed up, because I think that's very interesting. So here I have a very simple CDK application. It's written in Java. And it consists of a single stack that has a Lambda function and a REST API in front of it. And I've already deployed it, so I can test it here. So you can see here I get the message. So the Lambda itself is a very simple, trivial JavaScript Lambda with one file. And this is exactly what's deployed here. So now, of course, I can, invoke CDK watch, and I will pass the no logs switch to it, just so that we see the output clearly. Logs are super useful to see in the in your command line when you're using watch, but in this case we don't need them. We just want to focus on the output of the commands. So you see we get for the initial deployment, of course it says no changes, no surprise there. So I can do a change here, change number 1, and if I save that file, you see CDK watch sees that, triggers CDK deploy for me, using hot swap, as you can see from the warning, and after something like 10 seconds we're done, and if I refresh the Lambda here, now I see my change. Now, if we look at the output of the command, we see that actually in this case synthesis is the dominant time. So, the whole operation took just over 10 seconds, but almost 9 seconds of that was synthesis. So actually executing your CDK code and creating the cloud assembly inside the CDK.out directory here. But the interesting thing is that I'm just changing something in an asset here, right? So there's, in theory, no reason to run synthesis again, because we know it won't change, because I know this changes only to an asset, and I did not actually touch any CDK code to perform this change. So I've created a proof of concept of implementing that performance optimization, and for now I hid it behind the turbo flag in my local version of the CDK CLI. This has not been released yet, and probably this command line option is a little too funny, so it probably won't survive, but for now it's called turbo. And what we'll see when we invoke it with this command, after the initial deploy, of course, finishes. Yep, so we're done also roughly in 10 seconds. But now if I do a change and you see that synthesis time is actually 0, and that's because we completely skip synthesis, because the CLI noticed, hey, this changes to an asset, so I don't have to resynthesize the application. I can just deploy it, and you can see it deployed very quickly in less than 1.5 seconds, and we can see the change here. And I can do this many times, of course, right? And you can see every time the change is deployed in less than a second and a half. So yeah, quite a big improvement compared to the initial 10 seconds that we had, and I think it makes the development feedback loop that much faster. So yeah, let me know what you think, and if you think this proof of concept is worth it to expand further and maybe get it to production and released with the main version of the CDK. Thanks for watching.